Hi girls, so this lesson is about sketching quadratics. You can see there I've already got a number plane, and on that number plane I'm going to sketch a quadratic, and I will sketch it there. And before I do anything else, I just want to kind of point out the key features of this quadratic. The first thing we know is that it's concave up, which, should I try that again? Up, which means that a is bigger than 0, right? Normally we'd go the other way and we say a is bigger than 0, therefore it's concave up. We know here this thing is the vertex, and we'll talk about how to calculate that. These are the x-intercepts, and if you think about what we did in Monday's lesson, the sum and product of roots, for instance, the sum of these is negative b on a, so the vertex here would occur at the average of those two things, alpha plus beta on 2. In other words, negative b, here we go, negative b on 2a. So that's where the vertex would occur always, and then you'd find the y-coordinate. Here we've got a y-intercept, and that's really about it. Any parabola that we have, if we have 3 points, that's enough to uniquely identify that parabola. So the first case is, what if we've got a parabola in this form? What if I gave you that and I said sketch? What would you do? Well, first thing I would do personally is I'd say, well, okay, let's say a is positive. Let's just say we know that. That means it's concave up. And then I'd find the value of c. Let's just pretend that's positive as well. That would give me the y-intercept. And then let's pretend that b is negative for the sake of everything else. That would tell me where the vertex lies. That would tell me the axis of symmetry. So the axis of symmetry is minus b on 2a. So that's actually going to be positive as well. If you think about it, minus b on 2a, negative, positive, so the whole thing will now be positive. So essentially that means that the quadratic looks something like this. Right, this point here is the point C, this point here is the point negative b on 2a, whatever that is, and then whatever y value you have, who knows, just calculate it. And then you could just sub in any other point you liked. You could sub in x equals 1, and you'd get the point 1, comma, a plus b plus c. Right, that's the first type, and that's important to be good at being able to quickly sketch, because it will tell you a few things really quickly. The next type, which is probably more important and more useful, is what if I give you a parabola like this? Go away. Sorry, technical difficulties seemingly as always. So if I gave you a parabola like that, well, the most important thing is we now know the roots and we now know the concavity. Just for the sake of making it interesting, I'm going to pretend that a is negative this time, and then I'm going to pretend that this one is a positive number and this one is a negative number. Okay? So, in other words, it's actually x, it might be, for example, y equals negative 3, x minus 1, x plus 2. So, we've got concavity, concave down. We've got roots at 1 and minus 2, so we draw that, and notice minus 2, positive 1, so the turning point will be somewhere here on the left, something like that, minus 2, 1, and then we need a third point. The third point, always easiest to multiply these three things together, so minus 3 times minus 1 times 2, 6, that's the y-intercept. Okay. Now, my drawing is not very good because it almost looks flat in the middle there, doesn't it? I should really show that that is not actually the vertex, so I'll do something like that. Okay? That is the next type of drawing for a parabola. Again, hopefully you're already really good at this. The last type is the perfect square type. Purple. So, let's say y equals 2x minus 3 squared plus 4. So let's sketch this. You should think about these ones as shifts, and I'm probably going pretty fast because you hopefully already know this. So this here, concave up. This here means shifted right 3 units, and this here means up 4 units. So something like this, where the vertex can be read off immediately as 3, 4. Okay. Again, use x equals 0 and find the y-intercept. So that's 2 lots of 9 plus 4, so 2 lots of 9 is 18, so that's 22. The third point, the easiest way to do it, is to use symmetry, right? If you go across here to 22, that will be down to 6, because you've had to go across 3 units to get to the vertex, so you should have to go across 3 more to get across to 6. So this point here is 6, 22. It's the easiest way to do that. As a general algebraic rule, if I write a parabola y equals ax minus h squared plus k, then the vertex occurs at h, k, for exactly the reasons we talked about there. This is a shift h across, this is a shift k up. And if they're negatives, then this one would go left and this one would go down, for example. The last thing I want to talk to you about is different kinds of parabolas. So, I got a bit distracted by Mr. McLaughlin there. So, I can't remember exactly what I said, but we want different types of parabolas. And we've got 3 types. We've got positive definite, we've got negative definite, and then we've got indefinite. And we have 2 other types actually that sit inside here. You actually also got positive indefinite, negative indefinite, but I'll just kind of talk around them as we go. So here is an example of a positive definite parabola. Here is an example of a negative definite parabola. And here is an example of an indefinite parabola. Okay, and I'm going to now have a quiz question to ask what you think the definitions might be. So, hopefully you all got 100% there. Basically the definitions are to be positive definite. The word definite, actually, we'll talk about that first, means that the discriminant is negative, because you'll notice in both cases there's no solutions, there's no intercepts in either of them. Positive definite, you obviously need to be positive, you need to be concave up. Negative definite, you need to be negative. Indefinite just means there are 2 roots. Right? So all you need for that is discriminant positive. If instead of positive definite you change to positive indefinite, the only change you make is you have discriminant equals 0, and that just means a parabola that just touches the x-axis but is otherwise always positive. Right, that is positive indefinite. And then exactly the same for negative indefinite, pretend that touches. Right, so it's the same thing but discriminant 0. That's basically the theory you'll need. Hopefully we can spend all lesson on Wednesday drawing them. Have a good night, girls.